Hi, good day everyone. My name is Antonieta Dumabok. Today I'm going to conduct my laboratory exercise 007. The title of this activity is IP addressing exercise. Objectives: convert binary numbers to decimal and vice versa. Second, determine the importance of IP addressing in networking system and its subnet mask. Third, identify the three types of addresses: network, broadcast, and host address. And fourth, identify the network portion and the host portion of an IP address. Materials needed: one sheet of paper, pencil, calculator. Procedure: convert the following IP address to binary numbers: A 201.17.29.4 and B 192.168.1.1 and C 172.0.0.0. So before I convert the IP address into binary, I should write the bytes from 1248, 1632, 64, 128, and so on. So first 201 201 201 into 52, it can't be because the bytes is higher than the IP address. So we will start in 128. So 201 into 1 by 128 ay 1. So 201 list 128 equals 73 in by 64 1 64 minus 73 minus 64 is 9 by 32 0 9 by 16 0 9 by 8 1. So 9 minus 8 equals 1. So 1 by 4 0, 1 by 2 0, and 1 by 1 1. Okay, next 17 by 128 can't be. 17 by 28 can't be, and 17 by 64 can't be, 17 by 32 can't be, and then 17 by 16 1. So 17 by 6 minus 16 1. So 1 by 8 0, 1 by 4 0, 1 by 2 0, 1 by 1 equals 1. Next 29 by 28, 29 by 128 0, 29 by 64 0, 29 by 32 equals 0, 29 by 16 yeah 1. So 29 minus 16 13 by 8 1. So 13 minus 8 5 by 4 1. So 5 minus 4 equals 1. 1 by 2 equals 0, 1 by 1 equals 1. And then next is 4 by 28 can't be 0, by 4 by 64 0, 4 by 32 0, 4 by 16 0, 4 by 8 0, 4 by 4 1, and 4 minus 4 0, and 4 minus 4 0, and 4 0 by 2 equals 0. So 0 by 1 equals 0. Now this is the binary number that IP address 201.17 29.4. So I need to add that have bits in bytes. So 128 plus 64 plus 8 and plus 1. So this is 201. The answer is 201. This is correct. So next, so we need to add this one in the second. 16 plus 1. So because this is only has 1 bit, so plus 1 equals 17. So this is correct, 17. Then the third, 29. So 29, 16 plus 8 plus 4 plus 1 was 29. So this is 29. So it's correct. And then this is the 4 only. So we have only 1 bit in 4. So this is correct. So B. So B, IP address is 192.168.1.1. So 192 into 256 can't be, so we'll start in 128 bytes. So 192 and by 128 equals 1. 192 by minus 28. 192 equals minus 28 equals 64. So 64 by 64, 1. 64 minus 64, 0. 0 and by 32, 0. 0 by 16, 0. 0 by 8, 0. And 0 by 4, 0. 0 by 2, 0. 0 by 1, 0. So next, 168. 168 by 128 was 1. So 168 minus 128 equals 40. 40 by 64, 0. 40 by 32, 1. So 40 minus 32. 40 minus 32 equals 8. 8 by 16, 0. 8 by 8, 1. 8 minus 8 equals 1. 1 by 4, 0. 1 by 2, 0. 1 by 1 was 1. So next, 1. So 1 is by 28, 128 equals 0. 1 by 64, 0. 1 by 32, 0. And 1 by 16, 0. 1 by 8, 0. 1 by 4, 0. 1 by 2, 0. So 1 by 1, 1. And the same procedure, that 1 as well. Same. 0, 0, 0, 0, 0, 0, 0, 1. So this is the binary number of IP address 192.168.1.1. So if you will convert this one, it's same procedure than the first one. So you will add only the one has bit. So for example, 128 does have 1. You can convert this one. So we will you will find that number 192.168.1.1. So next, 172. 172. The letters A, 172 into 128 equals 1. So 172, 128 172 minus 128 equals 44. 44 by 64, 0. 44 by 32, 1. So 44 less minus 22 equals 12. 12 by 16, 0. 12 by 8, 1. So 12 minus 8 equals 5. 12 minus 8 equals 4. So 4 equals 4. 4 minus 4 by 4 equals 1. So 4 minus 4 equals 0. 0 by 2 equals 0. 0 by 1 equals 0. So the rest is 0, 0, 0. So you can write this 0, 0, 0. By 28, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So why is that 0, 0? Because the IP address is less than that and less than the byte numbers. So the same procedure you can add, but has bits. For example, 128 has 1 bit. This is 172. So this is the has bit 128 to 132 32 8 4, and the rest is the 0. So next convert binary to decimal number. So now I have this table showing 4 octets. I have to fill this binary to convert to decimal. And now I have to fill the binary into position. Okay, now I have to fill the binary from left to right. So 0, 0, 0, 2, 3, 4, 5, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 1. Then 0, 1, 0, 1, 1, 0, 0, 0. Then 1, 1, 1, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 1, 0, 0, 1, 1. And then forget all 0 and convert to decimal with binary ones. So forget 0. Then I have to multiply 2. For example, has one bit one binary in 2 5 times. For example, 2 2 times 2 times 2 2 times 2 times 2 times 2 times 2. So this is 32. And then 2 into 7. 2 into 7, 128. 2 into 9, 512. 1 512. 512. Okay, 11. 2 into 11. 2048. And then 2 into 12. 4096. And 2 into 16. 2 into 16. 6 5 5 3 6 6 2 into 17. 131 072. 2 into 18. 262 144. 2 into 24. 2 into 24. 16777 216. 2 into 25. 33554 432. 2 into 26. 67 108 864. 2 into 27. 134 217 728. 2 into 30 equals 1073 741 842. And 2 into 32 824. Sorry, 824. And 1 into 32 is 2147 483 648. Now I'm gonna add this one, all the numbers 32, 28, 500, 512, 248. So the final answer is 3 4 7 3 3 49280. 49280. This is the decimal number, binary number converted to decimal number. Then next, third procedure, network address 192.168.1.1, and subnet mask is 255.255.255.0. And A, what is the network address in binary? B, what is the subnet mask in binary? And C, what is the prefix length? Okay, so network address in binary is 192.168.1. So okay, letter A, what is the network address in binary? Network address in binary is 192.168.1. So now I'm gonna convert this 192 into 128 equals 1. So 192 minus 128 equals 64. So 64 by 64, 1. 64 minus 64, 0. So 0 by 32, 0. 0 by 16, 0. 0 by 8, 0. 0 by 4, 0. 0 by 2, 0. 0 by 1, 0. The next, 168 by 128, 1. So 168 by minus 128. 128 minus 128, 168 minus 128, 40. 40 by 64, 0. 40 by 32, 1. Okay. 40 minus 32, 40 minus 32, 8. 8 by 16, 0. 8 by 8, 1. So 8 minus 8, 0. 8 by 4, 0. 8 by 2, 0. 8 by 1, 0. So now 1. So 1 by 28, 0. 1 by 64, 0. 1 by 32, 0. 1 by 16, 0. 1 by 8, 0. 1 by 4, 0. 1 by 2, 0. 1 by 1 equals 1. And the same procedure. No, this is the network address in binary, and the rest is the broadcast. Now I'm going to put this binary. I'm going to put this all. So when you count the network in binary, it should count from left to right. So I'm gonna put this 1 1 1 0 0 1 2 3 4 5 6 7 8, and then this one 1 2 3 4 5 6 7 8, and then 1 2 3 4 5 6 7 8, and then 1 2 3 4 5 6 7 8. So you should count the CDR 28, CIDR 28 to find the whole to the broadcast. So you will count from right to left the network. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28. So the network up to here. So and the rest is you can count from left from right to left. So for example, this is the bytes. 1 2 4 4 8, and this is the last network in 32 bytes. So just add this 1 2 1 plus 2 plus 4 equals 7 plus 8 equals 15. So this is the broadcast network. So this is 15 is the broadcast network for the network address. Okay, next, what is the subnet mask? Subnet mask what is the subnet mask in binary? Okay, so I need to convert to binary. Subnet mask is 255 into by 28 1. So 255 minus 128 equals 127. 127 by 64 1. So 127 minus 64 equals 63. 63 by 32 equals 1. So 63 minus 32 equals 31. 31 by 16 equals 1. 31 minus 16 equals 15. 15 by 8 equals 1. And then 15 minus 8 equals 7. 7 by 4 equals 1. So 7 by 4 equals 3. So 3 by 2 equals 1. So 3 minus 2 equals 1. So this is the subnet mask, and the rest same procedure. You can write 1, 1, 1, 1, 1, 1, 1, 1. And then 1, 1, 1, 1, 1, 1, 1, 1. That 0 is the host for the subnet mask. So you can write only 0, 0, 0, 0, 0, 0, 0, 0. Next, letter C. What is the prefix length? The prefix length is the mask where the first 24 bits are 1 bits. So the prefix length is 24. So 24. The prefix length is 24. And then the next, letter E. In the network address 192.168.1.1, underline the network portion and encircle the host portion. So the network portion is 192.168.1. So the other one is the host portion. So this is the network address, network address, and this is the host portion. Ilang minuto na lang?
27 na.
So mayroon pang 5. Next, I'm going to answer the question. First, why do we need to convert the decimal value to binary numbers? In my opinion, this means that just two numbers, 0 and 1, are required by the switches to represent its state. On the other hand, if the computer used the decimal system, there would be 10 possible states to a switch. This is time-consuming and completely unnecessary. So to avoid the hassle and make things such as calculation simpler, computers use the binary number system. Now, you will understand why computers using binary numbers instead of decimal numbers. Question 2. Why all computing devices have an IP address? It is possible to have similar IP addressing among devices. Explain your answer. Every web-capable device needs an IP, Internet Protocol address to enable it to access the Internet. Without an IP address, computer would not be able to communicate with each other. Every Internet-capable device from your computer to your smartphone has its own unique identifying IP address. Yes, each device that accesses that Internet gets its own IP address. However, all the devices that come from one home or business can share one public IP address, and it is tagged with an additional number so that each device only gets its own data. This is called NAT. So although all the devices are sharing an IP address, if you look carefully, you will actually see the additional numbers, which makes that data have unique address for the individual user. And think of it this way. If you live in a house, you have a straight address and only one family can get mail there, but if you live in a huge apartment building, there is only straight address for the entire build, yet its family. So gets their mail because there is apartment number of each family. So if you ask if there is only one street address for the building, then the answer is yes, but it's ignore the fact that there is more to the address and that each family only gets exactly their email. The same is true with IP address. When you connect to any device to the internet, you get have an IP address that is one way or another is unique to you and only you. So question 3, what is the importance of the subnet mask? The main purpose of subnet mask when entered into IP setting or a device is to enable it to determine what IP address should be considered local to it and so can be discovered and communicated with directly and which IP address should be considered remote. When a device needs to access an IP address that is not in the same local subnet, it sends the traffic via gate your gateway, typically your ISP router, which then connects you to another network. Those on the internet without the subnet mask, your device would not how to route traffic and hence its importance. And fourth, what can you conclude from this activity? I can conclude that in doing above laboratory exercise, the student will learn the basic and complexity of computer language to be able to convert this into a more simple, understandable language by human.